Hello and welcome to this new video on logarithms. In this video, we shall be discussing logarithmic equations. So question 1 says, solve for the exact value of x, evaluate radicals wherever possible, leave answers as whole numbers, fractions, or radicals if they cannot be evaluated, no exponents or decimals. So these are just a couple of extra instructions. These are not very important. The main issue is that we're trying to solve for x. Like with any other equation, we start by isolating the term that has x. So we take this -7 here to the other side, it becomes +7. And of course, -7 plus 7 gives us 0. So we have negative log base 4 x equals to 0. And we have a negative inside. So we want to just get rid of it. And we use this ability of logarithms to transfer a number inside and out. So this negative is like -1. So we can write -1 here as a power. And we no longer have a negative inside. So our first task is to isolate the log itself. So now we have log on one side without anything else on the left. Now, how do we get rid of the log itself? Of course, we raise both sides to the power, to the base of 4, I mean. So we have 4 power log base 4 x power -1 equals 4 power 0. And the advantage of that is that this 4 cancels this log base 4. And we have x power -1 equals 4 power 0, which is 1. And of course, x power -1, we can take the power to the other side, and it just becomes 1 over -1, which means -1 at the end of the day. So x equals 1 to the power of -1, which is at the end of the day still 1. So the final answer here would be 1. Let's try another example. So again, our first task is to isolate the log. So let's take the 17 to the other side, comes -17. And -19 minus 17 gives us -36. And on the left, we have -12 log x equals -36. In this case here, we can just take the -12 to the other side. So this is another good technique. So let's get rid of the -12. And -36 over -12, we can cancel out the negatives. And we get 36 over 12, which is 3. So log x equals 3. If we have a log without a base, we can always add the base of 10 here. So we know that if we raise both of these terms as powers of 10, we can get rid of the log. So 10 and log base 10 cancel out. So we have x equals 10 to the power of 3, which is of course 1000. And this solves the problem for us. Further examples here that might just have radicals or fractions and stuff like that, just slightly more advanced. Again, our first task is to isolate the log. So we're going to take the -17 to the other side, becomes +17. And we said -20 plus 17 gives us -3. And on the left, we have -6 log base 4 x. Now, this -6 here can be transferred to the other side as well by division. So we have -3 over -6, which gives us +1 over 2. And on the left, we have log base 4x. Now we can raise both of them to the base of 4. So 4 power left equals 4 power right. These cancel out. And we have x equals 4 power half, which is equal to 2. And this would be the final answer here. For the fourth example, we're going to do the same thing. We're going to take the 8 here. So we get -8, which is -10. And on the left, we have 20 log base 2x. So this 20 here can be taken to the other side with division, and this equals negative half. We have log base 2x equals negative half. Now we can raise both sides to the power of 2, or to the base of 2, I mean. And 2 cancels log base 2, so x equals 2 power negative half. Now, they don't want exponents, so we have to find a way to write this properly without exponents. So we have a negative power, so we have 1 over 2 power half, which is 1 over radical 2. And this would be the final answer in this problem. So we're going to deal with natural logarithms here. We have 6 ln 2x plus 10 minus 4 equals 8. So similar strategy, we're going to isolate the ln. So the 4 goes there with a plus, and this becomes 12. So we have 6, let me write this again. We have 6 ln 2x plus 10 equals 12. Now we can divide by 6, and this gives us 2. We have ln 2x plus 10 equals 2. Of course, to get rid of the ln, we remember that ln x is the same as log base e x. So therefore, e power ln x is e power log base e x. And these cancel out, and we just get x. So we don't have to carry out this middle step here. We just take e as a base to both sides. So we have e to the power of left equals e to the power of right. And these cancel out. So we have 2x plus 10 equals e power 2. We're going to keep e as e. We're not going to evaluate the decimal equivalent. And we're going to isolate the x. So the 10 goes to the other side with a negative. And then we divide by 2. And this becomes our final answer. X equals e squared minus 10 over 2 is the final answer here. Let's try another example, number 27. We have 5 ln 7x plus 4 minus 9 equals negative 19. Let me just rewrite that so that I have enough space. So 5 ln 7x plus 4 minus 9 equals negative 19. So we can take the negative 9 to the other side, becomes plus 9. This cancels out. We get here negative 10. We have 5 ln 7x plus 4 equals negative 10. We can divide both sides by 5, or just cancel this here and put it over there. And this gives us negative 2. So ln 7x plus 4 equals negative 2. Now we take a base on both sides of e, and the e cancels the ln, and we get 7x plus 4 equals e power negative 2. We take the 4 to the other side with a minus, and then we divide by 7. So the final answer for x is e power negative 2 minus 4 over 7. And this wraps up this problem there. Now, before we proceed to more advanced examples, we are going to discuss what we call the change of base rule. It looks a bit complicated. We're actually going to use a much simpler alternative. So they say log base a x equals log base b x over log base b a. I'm just going to write the same thing exactly, but without the base. So just ignore this base here. Let's assume that this is just like base 10 or whatever. So in general, if you have a logarithm, let's say we have log 7 base 3, we can write it as a fraction of log 7 over log 3 without a base. And this sometimes is convenient and helps us solve certain problems, as we shall see next. So in this question on the left, we have log base 7, 3x squared plus 1. I'm going to immediately write that as a fraction. So log 3x squared plus 1 over log 7 minus log x plus 3 over log 7. Now, this is equal to 0, of course. If we take the second fraction to the right-hand side, it becomes positive. So we get log 3x squared plus 1 over log 7 equals log x plus 3 over log 7. Seeing that they both have the same denominator, we can just cancel these out together. This is as if we multiplied both sides by log 7. So they are canceled out. And now we just have log something equals log something. We can also cancel these out together. And we have 3x squared plus 1 equals x plus 3. Now, we want to solve this equation. This is a quadratic equation, so it's a good idea to bring everything to one side. We have 3x squared plus 1 minus x minus 3 equals 0. So 3x squared minus x minus 2 equals 0. You can use your calculators to evaluate this equation, and you will get x equals negative 2 over 3 and x equals 1. Now, you might have studied this before when you did radical equations. Whenever you solve an equation in logarithms, you have to check that your final answers actually work. And in order to do that, you have to take these values and plug them into the brackets inside the log in the question, and just make sure that these values do not give a negative result. So let's take 3x squared plus 1, for example. And let's just write x plus 3 here. And let's substitute negative 2 over 3 and 1. So for negative 2 over 3, if we plug it in here, it becomes 4 over 9. Multiply that by 3, you get a number, 4 over 3, I think, and then you add 1, so you get 7 over 3. So all we care about is that this number is positive. If it's positive, then it's fine. If we put negative 2 over 3 in this equation, we're also going to get a positive number, obviously, because negative 2 over 3 plus 3 is a positive number. Incidentally, it's also 7 over 3. So that's positive. But bear in mind, the task is not to make sure that these are the same. They don't have to be the same. They just have to be positive. We're just checking that they are positive values. If we do the same thing for 1, we get here 4 and we get here 4. So all the values here are accepted. So both of these solutions are correct. We do not need to reject either solution. Let's try the second example now. Again, the initial part is quite easy. Take this here to the other side. So, and you rewrite them as over log 5 and over log 5. So let's just remove this 5 here and remove the 5 here as well. And then let's take the fraction to the right-hand side. So this fraction, once it moves there, it becomes positive. So we get this equation here, where they are equal to each other. I believe this part is fairly simple. Once we reach this equation here, we know that we have the same denominator, so it can cancel out. And we get this equation, and then we can cancel the logs out as well. So we end up with this equation right there. It's just the same thing without the logs. Now that we have this equation here, we can just take these to the left-hand side. And we get 2x squared plus 6 minus 3x minus 5 equals 0. And we want to simplify this so that we can input into the calculator. So 6 minus 5 gives us positive 1. So we get 2x squared minus 3x plus 1 equals to 0. Now we have an equation that we can insert into the calculator. And we get these two results here. half, and 1. And we have to check that these two values actually work. They don't give us negative results when they're plugged into these expressions. So you have 2x squared plus 6. You have 3x plus 5. And you have half and 1. Just make sure that the two numbers do not give negative values. If you plug half into here, I think you get 6.5. If you plug half into here as well, you get 6.5. It will not always be the case that these two numbers are the same. You just care that they are positive. Put a 1 in both equations, you get 8 and 8. So here, both values are accepted because all the values in the table are positive. Next, we're going to try examples where one solution is rejected. So let's look at these two examples here again. So first step is I remove the base and I insert over log 5 over log 5. And then we take this fraction here to the right-hand side. So we now have this fraction. We move it to the right. Of course, this sign has to change. So that's why it becomes a negative. And that's not a problem. We can handle that later on. But for now, all we have to do is cancel the log 5 with the log 5. And we end up with the numerators only, which is this equation here. Now, in order to cancel the logs, I cannot have any number outside of the log. So I have to get rid of this negative. And the good way is to insert it as a power onto the bracket like this. And we just cancel it out from here. Now that we've done that, we're allowed to cancel the logs because we only have log on each side. We don't have anything outside of the log. So we can cancel out the logs and we end up with these brackets forming an equation. So how would we solve this equation with a power of -1? This is quite simple, actually. All you have to do is just flip this expression because it's to the power of -1. So you can flip it. You can get 1 over 2x minus 3. And now you have this bracket equals 1 over this bracket here. You can take this denominator and transfer it to the left, but it multiplies the bracket. So the 2x minus 3 goes here. And now you have 2x minus 3 times 3x minus 2 equals 1. And in this case, you're going to have to expand these brackets in order to solve. So that's what I did next. I multiplied 3x by 2x. So 3x times 2x gives us 6x power 2. Now 3x minus times -3, I mean, gives us -9x. -2 times 2x gives us -4x. And these two together would give us +6, hence this expression here. And all of that equals 1. Now I need to further simplify. So I have these two terms have x, so I can add them up together. -9 plus -4 gives us -13x. Now that we have a standard quadratic equation, we can input that into the calculator and obtain the results, which are half and 5 over 3. And we have to check both numbers or both results in each term that has a log. So the two terms here are 3x minus 2 and 2x minus 3. So let's just write them down. 3x minus 2, 2x minus 3. And we have two numbers to check, which are 1 over 2 and 5 over 3. So if we plug here 1 over 2, we get 3 times half, which is 1.5, minus 2 gives us -half. As soon as we see a negative sign, we know that this value is rejected. We cannot accept half as a solution because this would give us log of -half. If we plug half into x here, we get -half. And this is undefined. We cannot have a log and a negative inside. So this solution is rejected. I don't even have to try to find this number here. We don't care about it because this is a rejected solution to begin with. Now for the 5 over 3, if we plug it here, we get 13. And if we plug it here, we get 10 over 3 minus 3, which is 1 over 3. Again, like I said, we don't have to get the same result. We just have to ensure that they're both positive numbers. And this is the case here. Hence, this is accepted. So you're going to see here in the second check, we got an accepted solution. Now, for the second equation, let's carry out the same procedure. So for the first step, I just removed the base and I wrote it as a denominator, as a fraction. And then I transferred this fraction here to the right-hand side, obtaining this equation. And then we have the same denominator on both sides, so we can cancel them out. Now we have this equation here. Now I have log equals log, so this is quite simple. Just cancel the logs out, and you end up with this equation right there. Take everything to the left-hand side. So this goes there and this goes there. So an intermediary step here would be x squared minus 6 minus 3x minus 4 equals 0. And minus 6 added to negative 4 gives us negative 10. So x squared minus 3x minus 10 equals 0, which is what we got right there. Multiply 3 on your calculator, and you get 5 and negative 2. These are the two solutions. We have to try them with each expression. So x squared minus 6, 3x plus 4, and you have 5 and negative 2. Use your calculator to evaluate. This gives us 25 minus 6, which is 19, so that's okay. This gives us 19 as well, so that's fine. For the negative 2, if you put it here, you get 4 minus 6, which is negative 2. And I won't even check this one because this is rejected. And this here is accepted. So now we are done with the problem because we have accepted the correct solution and rejected the incorrect solution, and we can move on. So for the final pair of problems, we have an equation that looks slightly different, but we're going to carry out the same procedure as well. So we have a base here. Instead of the base, I'm going to write it as a denominator. Now I have something over something equals 2. I'm allowed to take this expression here and move it to the right-hand side. And I end up with 2 multiplied by log 2x plus 1. In order to be able to cancel out the logs, I cannot have anything outside of the log. So first, this has to go inside as a power. And this gives us this expression here. Now that we have log equals log, we are allowed to cancel them out and just equate the inner expressions. And the rest is just basic algebra. So this here has to be expanded. Of course, you should know how to expand something to the power of 2. You can write it as 2 brackets like this. 2x plus 1 times 2x plus 1. This is 4x power 2 plus 2x plus 2x plus 1, which is 4x power 2 plus 4x plus 1. And this gives us the expression right there. Now, since these are quadratics, it's a good idea to bring everything to the left-hand side. So I'm just going to take all of these and move them to the left. But since I'm moving them across, their signs are going to change. So I get 3 negatives here instead of the 3 positive values. So it becomes minus 4x squared minus 4x minus 1. Next, we figure out the like terms. So we have 3x power 2 minus 4x power 2. Cancel these out together. You get negative x power 2. And you have 10x minus 4x. So these cancel out as well, and you get 6x. 10 minus 4 equals positive 6, obviously. Finally, you have negative 4 and negative 1. These cancel out, and you get negative 5. You can just input this equation as it is into the calculator, and you're going to get the results, which are 5 and 1. Now we can type in the results onto the table. So we have two expressions here. We have 3x squared plus 10x minus 4, and we have 2x plus 1. Excuse me. 2x plus 1. And the two values are 5 and 1. So let's check each and each. Just plug the 5 into this expression using your calculator. This is going to be 75. This is 50 minus 4. So 75 plus 50 minus 4. You don't even have to get the answer. It's just all you have to do is just make sure it's a positive number. And in this case, it will be. If you put the 5 here, you get 2 times 5, which is 10, plus 1 gives you 11. Again, it's a positive value. So the 5 is accepted. If we put the 1 into this expression here, it gets 3 plus 10 minus 4, which is a positive number. It's 9, actually, which is okay. And then if you put the 1 over there, you get 2 times 1, which is 1, plus 1 gives us 3. So again, both values are accepted. So in this case, both results are fine. For the final question in this video, we are required to solve this equation here. Again, first step would be to write as a fraction, and then take this guy and move it over there, which gives you the second step here. And in order to cancel the logs, I need to first get rid of this 2. So we use the power rule, we cancel this here and put it inside, obtaining this expression here. Then we cancel out the logs, and we have this expression equals this expression, x plus 7 squared. I'll do it for you just to make sure. X plus 7 multiplied by x plus 7. This gives us x power 2 plus 7x plus 7x plus 49. So x power 2 plus 14x plus 49 is the solution to that. And we have that on the right-hand side right here. Now we bring everything to the left. So this goes there, this goes there, and this goes there. Of course, they all have to have negative signs since they're moving across the equal from right to left. So you have negative, negative, and negative. And we collect the like terms and add them up. So these two add up. We get x power 2. These two add up. We get negative 23x. And finally, these two add up. We get negative 50. We plug those into the calculator. We get our two results. And we create the table. So the expressions here are 2x squared minus 9x minus 1 and x plus 7. And the two values are negative 2 and 25. So you can use your calculator to figure these out. You're going to find if you put 25 into if you put negative 2 first into the first expression, that you will get 25 as a result. If you put negative 2 in the second one, you're going to get 5. These are both accepted. If you put 25 into the first expression, you're going to get a very big number. We don't really care about the number, we just care that it's positive. And same thing here, you're going to get 32, which is positive. So both values are accepted. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.